across the individual resistors is equal to the voltage rating of the battery. So basically, if you calculate all the voltages at every resistor, and you add them all up, that'd be equal to whatever is at the source. Okay, that's what this is saying. So like, if I lost, let's say we had 5 volts and I lost 2 volts here, 3 volts there, then the total voltage loss or drop is 5. You just add them together. That's all that's saying there. Next one. But the most important one is the resistance, because that's what you need to calculate first before you do anything, is the overall resistance of the collection of resistors. So there's a bunch of resistors. Is equal to the sum of the individual resistance values. So here's the formula for that. So the R total, resistance total, is equal to R1 plus R2 plus all the way till the last one. So if they're in series, you just add them together. It's very easy. Okay. So these are the 3 things I need you to remember, or at least make a note of for series. Okay. Now let's talk about parallel circuits. And I'll also send you some videos about circuits to help you out in case you need more examples, because it can be a little weird the first time you do it. Okay. All right, parallel circuits. So the voltage drop is the same across each parallel branch. Okay. Next one. The sum of the current in each, sorry, I lost my train of thought there. The sum of the current in each individual branch is equal to the current outside the branches. Okay, one last bullet point here for resistance. Okay. The equivalent or overall resistance of the collection of resistors is given by the following. This form is a little more annoying, but you can do it on your calculator or Excel pretty easily. So basically, it says that 1 over R total, or R equivalent, is equal to 1 over R1 plus 1 over R2 plus 1 over R3. Now, if you prefer this formula, because that way you don't do any thinking, right? Just do this. The R total is equal to that same thing, just put a -1 on the outside. Okay. So like if you do this in Excel or your calculator, add the fractions inside the parentheses and put -1, that'll give you the total. Otherwise, you're going to get the reciprocal if you don't do that. Okay. So these formulas are equivalent. All right. Get some more notes here before we go any further. Okay. So in series, same. Yeah. So in other words, if you had multiple currents, let me go back, make some extra notes for you. So don't forget. So suppose you have multiple currents, right? They will all be equal to each other. That's what this first bullet point is saying. Right. They will all be equal. Okay, in series. So I can come up with another one. In series, voltages are not equal to each other. Okay. And I already put the resistance formula. Parallel circuits, voltages are equal to each other. So in this guy here, V1 is equal to V2 is equal to V3, equal to the rest. Okay, and parallel for voltage. Oh, wait a second. That was the voltage, wasn't it? Shoot.
I got a quick question on the voltage.
Sorry about that. I didn't hear that last. Somebody say something?
Yeah. Is the voltage? Are you saying is the voltage source one, voltage source two, or is it voltage of resistor one, voltage of resistor?
Yeah, voltage of resistor 1, etc. Right.
Okay.
Let me put up my volume. I don't know why it's so low.
Would it be
One
VR
second.
one and then VR two?
Yes. Yes. One moment. My headset's super low. Where is it? Yeah, it's better. Yeah, did that answer your question? I'm sorry, I don't know if I caught it all.
Yes. Yeah.
Okay.
I just want to make sure that was the voltage of the components instead of every voltage source in the circuit.
Yeah, we're not gonna have. We shouldn't have any multiple sources, not for these examples.
Okay.
But yeah, it's implied because there's only one source for all these. What was I doing? Oh yeah. But a good question though. Okay, so in parallel, they are all equal. Voltage. Now the sum of the current. We said and then parallel. Yeah, so this is kind of worded weird because it's about the branches. Um, this all makes sense. No different branch. So parallel. Yeah. So this would be, it's written this way. Okay. Should be everything. Okay, and we're going to be using Ohm's law, of course, the entire time. So let me go ahead and give that to you now. Ohm. The voltage is equal to current times resistance. In other words, V is equal to I times R. All right. So let's do some examples so you can start seeing what equivalent circuits are and how you find resistances, etc. You guys have any questions so far? Okay. All right. Let's look at a diagram here. Equivalent circuits and the sum of resistors or resistance. Okay. So let's see, we have this one diagram here. See if I make one up. Close the circuit here. So let's say this is a 12-volt source. We have one resistor R1 equal to 2 ohms. So resistance units are going to be in ohms. You can't write the omega symbol very well, but it's supposed to be an omega symbol. This will be R2, and that's equal to 4 ohms. R3 will be equal to, I'll make it the same, 4 ohms. So just real quick, these two resistors are in parallel. Okay, so we need to deal with this first. If you create an equivalent circuit, it becomes a little easier to figure out the total resistance. So these two are in series with this guy, but these two are parallel to each other. Okay, so an equivalent circuit would be something like this. If I combine these two into one, I need to calculate the equivalent resistance. This one I'm not changing, still the same. So since these are parallel, this new resistance, we'll call it equivalent, right? That would be equal to 1 over 4 plus 1 over 4 ohms, right, to the negative 1. So this will be in ohms. So that is approximately what? 1/4 plus 1/4 is a half, right? Reciprocal of a half should be 2 ohms. So this is just 2 ohms right here. So the total resistance would be this guy plus that guy because now they are in series. So this is going to be R1 plus R2, or R equivalent, I guess. That's what we called it. So this would be 2 plus 2 ohms. So 4 ohms total. Okay. Is there any questions about this? Okay, so there's another example here. Yeah, I'll do it on the next page. This one will make it a little bit more complicated, and then we'll calculate current and etc. Okay, given a circuit diagram, find total resistance. Current and voltage at each resistor, or the voltage drop is a better way to think about it. All right. No, actually, one moment. Example. All right, where was I? Okay, here we go. Okay, so 60 volts here. R1 is 5 ohms. R3 is 8 ohms. R2 is 8 ohms. R4 is 6 ohms. Okay, so let's create an equivalent circuit. Make this a little easier. We don't really have to, but let's make one just for fun, right? So I'm going to combine that parallel circuit into one. Okay, so this guy will be an equivalent circuit, or resistor rather, which will be 1 over 8 plus 1 over 8 to the negative 1, which would be 1/8 plus 2/8 is 1/8 plus 1/8 is 2/8, which is 1/4. The reciprocal of a fourth is 4 ohms. Okay, and this one is still 6 ohms. So using this information, our total would simply be, right, this should be 5 ohms plus 4 ohms, which is the one we found, plus 6 ohms, because these are all now in series. You just add them together. no big deal, right? So it's 15 total ohms for the entire resistor. Okay, so now that we have 60 volts, forgot. Now that we have the total resistance, we have the total voltage, we can calculate total current. So total current, we use I, by the way, is going to be equal to voltage total over resistance total, which is equal to 60 volts divided by 15 resistance ohms, which will be 4 amps. Okay. All right then. Now you start calculating the current at specific locations using the ideas we wrote down earlier, right? We said that current should be equal for parallel branches. So the current drop at R1 and R4 should be equal. Okay. Let's see, current, yeah, current at those places should be the same. All right. All right. So the current 1 at resistor 1 should equal the current at resistor 4, right? Using the idea of, since the original, right, they were R1 right here. Since R1 and R4 are parallel, they should be equal. Now, all we need is 2 and 3. 2 and 3 are parallel to each other originally, right? So current 2 and current 3 are equal to each other. So what is I1? Right, so where's my calculator at? Oh, here it is. Okay. Write down the ohms law somewhere here. Use IR, yeah. Okay, so if I solve for current, current should be equal to voltage over R, right? So current 1 should simply just be
Take the 4 amps, multiply it by the 4 ohms, and then since it's the same resistance, you divide by 2 and get 8 volts going across to each resistor.
Yeah, for the voltage, it should be, let me see here. For this example, you're talking about for voltage 1?
Yeah, for the parallel resistors.
Yeah, here they should have the equal current, but
Correct.
the voltage will be different.
Correct.
What
I
did
thought
you
you
get
were.
for the voltage, or were you doing current?
So I got VR1 is 20 volts, VR2 is 8 volts, VR3 is 8 volts, and VR4 is 24 volts. So the R4 with the 6 ohms is 24 volts. Is that
Your first voltage is right, and your V1 and V4 are good. Your V2 and V3 are not. What'd you get for your first current?
4 amps?
Yeah, 4 amps. Yeah, that's right, because that's what's coming out.
Yeah. So
This
I
is
get
total.
so for the REQ for the 2 and 3, I guess it would be 16 volts for the parallel branch, right?
Yeah, yes,
But
that's
over,
right. That's right.
yeah, over each individual resistor would be 8 volts for, yeah, okay. Combined total is 16 volts.
Yeah, there you go. That's right. So I just got spaced out there. That phone call earlier. All right, so you guys agree that the total current is 4 amps when it comes out of the battery, since we use the total resistance to calculate, which should be equal to I4. These are good. Now, how do we calculate I2 and I3?
I2 and I3 would just, it'd be the same principle, just divided by 2 since they're the same resistance.
Yeah, it would be the same. Well, together, they would be equal to this, right? So I2 and I3 would be equal to 2 amps. Okay, once we have that, voltage shouldn't be 2 amps, right? All right, so we can simply just use our formula at that point. Voltage 1 will be equal to current 1 times resistance 1, which is equal to 4 amps times resistance, which is going to be 5, which gives us our 20 volts. Okay. Voltage 2 would be same. I2 times R2 is equal to 2 amps times our resistance. 2 was what? 8, right? So you got the 16, right? Okay, V3 should be the same deal. Let's see here. Yeah. I3 times R3, which is equal to 2 amps times 8 amps, or times 8 ohms. V4 will finally be I4 times R4. I4 being 4 amps times 6 ohms, yeah, 24 volts. Okay, so these are all theoretical values, right? When we get to the lab, we'll calculate, we'll actually measure and see how close they are, okay, to reality. But mathematically, these are correct. Right? Okay. But the big idea I want you to make sure you remember is finding the resistance. Okay, it's a big deal. But let's show you what I'm going to have you actually do by hand. Let's see if I can find it. All right, so the point of this next lab basically is to create a table in Excel, calculate all these values automatically. That way, when you plug in the values you want, it'll find the stuff that you need. Okay. So we're going to use this guy as our example in Excel. Okay. Go ahead and draw this thing before we switch screens to Excel. And please open an Excel document. You're going to need it. Hopefully we got enough time here. And if not, I'll send you some more videos on the circuits, because you're going to need to understand that deep understanding, just the basics. Okay. But if you have experience with circuits already, then that's even better. But I do not expect it. All right. R1 is 270. We'll probably do this during the lab as well. But for now, let's do it theoretically. R2, 220. 220. Okay, let's get the Excel file out. All right. This is the whole point of the lab. You're going to have your voltmeters out and your actual resistors, and we're going to build the circuits. We're going to build a circuit that we just drew on the paper, and then we're going to measure it using our tools. Okay, you're going to measure resistance, current, voltage, etc. So here are the, so make it look a little box similar to this. Here's the resistance area, so R1, R2, R3 from the paper, right here. Now, this one, we'll type it together. I did it earlier just to make sure I have the right number. And delete this. So remember that R2 and R3 are parallel to each other. So that means you would add R1 to it, right? This guy plus the inverse of, so in other words, 1 over this plus 1 over this to the -1. Okay, you see how what I wrote, right? I'm doing R total all at the same time. Let me shift back real quick. So I'm doing R total to be R1 plus the of these two resistors. Okay, so I just did it all at once. The other examples we did piece by piece, but you don't have to. Okay, so the theoretical resistance is about 359-ish. Okay, point something, but it rounded to 359 automatically. Okay, so there's my total resistance. So we can go calculate the current. So the current is, or the voltage was 5 at the source. There we go. So they added a battery, 5-volt battery or whatever. So our current we'll calculate simply by saying, where is it? One. That's weird. Sorry, got distracted. All right, so equals 5 divided by the total resistance. So there is my voltage, my current at this coming out of the source. Okay. Before there's any drops or anything. Once you have this, you can come in here and create another formula, right? Delete the one I had in there. So using Ohm's law, we said the voltage is equal to resistance times your current. Okay. Now the last one, and another way we can think about it is in terms of voltage drops. To find this guy here, you could say, you know what? I know I have 5 total, so 5 minus this amount should give me these two, right? So you could say, you know what? I have 5 voltage coming from the source here, minus the drop from the first resistor. Okay, now this one is equal to V3 based on the formulas we wrote down earlier, right? Because these are parallel, so the voltages are going to be the same. Okay. And once you have that, you can calculate these by using these formulas, right? Because we know that voltage is equal to phi R, so that means that current is equal to voltage over R, which means that resistance is equal to voltage over I. So using these formulas, you can create your own little Excel. So I expect everyone to make one of these for each circuit that I'm going to assign them. And then we'll measure them together and see how close you are. That's the goal for this week and next week. Okay. So this one would be, what's it? E5. Yeah. So to find the current here, do this guy divided by resistance. And then you can drag it to do the other two. Anyway, almost out of time. So I'll send you some information in a few minutes. Do you guys have any questions? We're gonna keep talking about it all week, but any questions at the moment? All right, well, I opened up homework 6 for the regression stuff. Just uploaded by tomorrow night. It was closed and I didn't notice, so I'll use it tomorrow night.
For the homework, is it the Word document?
It was shoot, I forgot. I think it was. What was on there?
The Word document had like a couple vertical graphs, and you had to plot them, and then.
Yes, it was that worksheet. That's right. That was the homework for homework 6.
Okay. I tried to submit that, and I don't know if anyone else ran into this. The submission is only looking for an XLS file or a CSX file.
Oh, I see. Let me fix that right this second.
Okay.
Yeah, I think I put Excel thinking you would use it, but the worksheet was in a Word file.
Okay, because I put the answers on the Word document, but I have an Excel, I guess, file for the work shown, with all the regressions on it. So if you want to see both, I guess if you could open up for both file types.
Yeah, I removed the file restriction, so you can put either or both.
Okay, cool. Thank you very much.
Yeah, sorry about that. All right, guys, we'll see you Wednesday, and we'll talk more about circuits.
Have a good night.
You too.
Thank you. Have a good day.
Have a good night.